Welcome to another live stream from Emerald Hills Skies. We're here on the outskirts of Louisville, Kentucky, and we've got our planetarium program lined up here so that we can see M45, better known as the Pleiades. And let's just zoom in on the Pleiades so you can see what they look like in our planetarium software. Planetarium software is software that lets you simulate the look of the night sky. You can see there are these bright blue stars. Actually, these stars are young, relatively young, and they're shining through a cloud of dust. And because they're so young, they're still kind of bluish tints, so they make the dust look blue. You can see there's at least 1, 2, 3, 4, 5, 6, at least 7, maybe 8 stars that kind of stand out, don't they? Actually, when you look at the whole field inside of this red rectangle, it's a beautiful open cluster, isn't it? And our theme this week prior to Christmas is Christmas clusters. So this is a close-up on one of those clusters, Pleiades. Sometimes I think clusters kind of get a bum rap. People sort of think they're boring. Well, this one's not boring. To get an idea of where Pleiades is located, maybe it's a good idea to kind of zoom out from it and look at the big picture in the night sky. Let's see. Let's turn on the other constellations here. A good way to find Pleiades is to find Orion. And a lot of people know how to find Orion. You got those 3 stars that are across the belt. Kind of got a shoulder or 2 up here at the top and a sandal or a boot or 2 at the bottom. There's a sword here. And a lot of times you can picture a bow and arrow. Well, if you took a line and extended it with the belt in the direction of the bow and arrow, that line would pass through C41, which is commonly called the Hyades, and come right over to M45, the Pleiades. The Pleiades are a naked eye cluster, one of the closest clusters. In fact, the Hyades probably is the closest, maybe at about 100 light years. Pleiades wouldn't be much farther than that. I don't know, 400 light years maybe. Let's now, as we kind of zoom back in, let's get rid of those other constellations again so we can focus on, let's kind of remember what this looks like. And now let's go over to the live telescope view of the Pleiades right now. And to do that, we're going to go to another software called SharpCap. And this is a live view of what you can see through our 11-inch RASA. See if I can show that to you. Down here on the right-hand side, you can see the scope on its tripod. So we're kind of looking up over the shoulder of the 11-inch RASA with camera view here through the ASI. It's an ASI 2600 MC Pro. It's an APS-C, pretty high res camera, something like 6,248 by 4,176 pixels. But there's the scope view of the scope itself, and now this is another view of a wide field camera riding on top of the scope. And when you look at it, you can ask yourself, what's all that glare? Well, that's because we have an 86% moon tonight. So that's why we chose these clusters, because we can see these even with that bright moonlight shining down us. We're also located on the outskirts of Louisville, and there's a light dome over Louisville, Bortle 5, Bortle 6. And using these electronically assisted astronomy techniques, EAA, we're able to look at Pleiades. But you notice we're not seeing that nebulosity yet. So let's see if we can fix that. We've got our exposure set up so we're taking 20-second exposures. That's what this is. 20-second exposure at gain 100. Let's start live stacking these pictures. What that lets us do is it kind of averages together those pictures so that you kind of get an accumulated look or a view. And right off the bat, from the very first couple of frames that are added, you can start seeing some of that nebulosity. Now we'll do quick reset over here in the side display histogram, and it's kind of giving me fits tonight because the moon is so bright. We'll do a white balance here, and boy, I tell you what, the moon is giving us fits. I kind of like for that blue to be up a little bit more than that. I think I'm gonna, there, that's better. And this dark black level, I usually put it right in front of that peak. And that blackens the sky just a little bit more. Makes the sky a little bit dark. You don't want to make it so that it starts pulling away that nebulosity. Now we're looking so far at 3 frames of 20 seconds each. Let's see if we can boost that mid just a little bit more to start seeing a little bit more of that nebulosity. Now, this is the live view. And again, if you can see our scope here, the telescope's pointing right up at Pleiades. Right now it's located in the sort of southwest sky. Again, you can trace over from the belt of Orion to be able to find it. Kind of over there in the southwest sky. And this frame of this Rasa telescope with this ZWO ASI 2600 MC Pro camera is just perfect for the Pleiades. We've got this frame completely wide open, so we're not zooming in a bit on that sensor. This is the whole frame. And look how that's the top of the little tiny looking dipper type thing of the Pleiades. And then it comes down here. Remember we said 1, 2, 3, 4, 5, 6, 7. Depends on which stars you count. There are at least 100 or two. You know what I like? I like this little straight row of stars here. Look at these. Actually, if you go back to this tail and start counting here, 1, 2, maybe don't count that one. 3, 4, 5, 6, 7, 8. These stars, it's kind of like they're pointing to this thing. And I don't know what this looks like. If you cock your head to the side, I think it kind of looks like a tiny, tiny, tiny dipper. You know, you got the Big Dipper, Ursa Major, the Little Dipper, Ursa Minor. Well, this is the Tiny Dipper, M45, the Pleiades. Tell you what, let's go back over to our planetarium software real quick so that you can compare. Now that you've looked at it live, now this is looking at it in the planetarium software. So this is sort of like being inside a dome of a planetarium. And these stars are traveling together. This is not like optical illusion of a bunch of stars that are at all different lengths from us. These stars are traveling together as a group. They're kind of hanging together. They're a crowd, you know, they're buds. And we used to think that this nebulosity was maybe part of the cloud that might be quoted as explaining to kind of form them. But now we know in recent years that they just happen to be passing through this cloud of soot and dust. And the blue color of their stars, it's kind of lighting up these clouds as if with backlighting. It's doing a lot more than that. It's actually ionizing the clouds a little bit, like making them phosphorescent a little bit. Now remember that series of stars I was pointing to? Here they are. At least 1, 2, 3, 4, 5, 6, and you can go ahead and count 7, 8. This little line I think is so cool looking, and it points right at this star. And you know, all these stars have names. It's really a beautiful cluster, isn't it? I think sometimes clusters get a bum rap because people think they're boring. Like I say, this one's not boring. One more time, let's go back over to our live view in SharpCap. And remember, we're adding these frames together. This is 4 minutes and 40 seconds. And now you're already starting to see that nebulosity in just 4 minutes. And look at how those stars are painting that soot with this beautiful backlit phosphorescence, making an amazing picture for us to see. And we are thankful that you joined us tonight for this Christmas cluster series to be able to see M45 live from Emerald Hills Skies. Thanks for joining us, and we hope to see you back here again. I hope you'll stop back often. And if you like this kind of content, please subscribe to the channel and give it a thumbs up. That helps other people find it. We don't make any money or anything off of it. We're just trying to get the word out about the beauty of the nighttime sky, and we appreciate you being a part of that. Join us on another stream anytime, and we'll look forward to seeing you then. God bless and good night.